All right, we're on to FRQ number 4. Remember, this is a non-calculator problem. We're going to solve part 1. Solve g of 10 for all values of x in the domain. All right, so let's look up here. We are not limited to positives, negatives, or zeros. There's no limitation what I can input in for x. Let's get started. So I'm going to plug in 10 equals e to the x plus 3. Now after this, I'm going to take the ln on both sides, or log base e, however you choose to write it. Log base e to the left and to the right. Okay, on the right hand side, I get to bring down the x plus 3, and I have log base e of 10. And we're going to subtract 3 from left, subtract 3 from the right. Now you can leave it as log base e, or you may choose to write ln of 10, subtract 3. So ln of 10, subtract 3 equals x. Make sure to put this in parentheses or put that negative 3 out front. That's going to be our first part for section A. Let's look at section B. All right, so now we have the arc sine of x divided by 2. Let me grab a new piece of paper. Okay, so just like we did for the first part of A, we're going to do the same thing. I'm going to replace this with h of x. So I'm going to have pi over 4 equals the arc sine of x over 2. Now, in order for me to remove the arc sine, just remember, like opposite adding and subtracting, opposite multiplying and dividing, these inverse operations, squaring and square root, well, sine and arc sine, or cosine and arc cosine. So I'm going to do the sine to the left and to the right, and I'm going to put what was all there. Okay, now I'm left with pi over 2 equals, and now I need to ask myself, what is the sign of pi over 4? Here's pi over 4, so 1, 2, 3, 1, 2, 3. So it's going to be the square root of 2 over 2. Okay, well, let's multiply. So we have 2 times the square root of 2 equals 2x divided by 2, divide by 2, and x equals the square root of 2 reduced down. Okay, let's make sure you can see that before I go ahead and move on to the next section. Okay, let me grab this new piece of paper. Let's look now at part B. Okay, so part B gives us function j and it gives us function k. And we are asked to rewrite it as a single log with a base 10, no negative exponents, and so on. Okay. All right, let's go ahead and do that. So I am going to go ahead and recognize that addition turns into multiplying and subtraction turns into dividing. So I have j of, and let me move this up even more so that you have full visibility of me doing my work. There we go. So I have j of x equals log base 10 of 8x to the 5th times 2x squared. Subtraction turns into division of 9. This has to go up here. This has to go up here. Of x to the 9th. You can only do this when you have the exact same log base. So these are all log base 10. All right, now we got to clean this up and make it nicer. Okay, you ready? 8 times 2 is 16. When you have the same base and you're multiplying, you keep the base and add the exponents. And on the bottom we have x to the 9th. We're not done yet. We can still clean this up. I don't know why I have an equal sign there. Okay, when you have these exponents, we're going to take the top minus the bottom, or some people like to do it like this way. I'm going to put 7, 1, 2, 3, 4, 5, 6, 7, and 9 on the bottom. Let's make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 7 on top. So we can cancel 1 for 1, and you can see we're left with 2 on the bottom. Now all of this is great, except remember we can never have 0 as the value behind. We can never have 0 on the bottom of a fraction. So this is when x is not equal to Oh, actually, we can never even have a negative behind here. So when x is greater than 0. When x is greater than 0. Okay, let's look at the next one. And here they want us to rewrite it as a single term of tangent. Ooh. Well, I recognize that sine squared plus cosine squared equals 1. So if I subtract sine squared to the opposite side, I have cosine squared equals 1 minus sine squared. So I have k of x equals cosine squared over sine. And then I can rewrite this as 1 over the cosine, because I know secant is 1 over cosine. Remember to show all of your steps. I recognize that cosine squared is cosine of x times cosine of x. And I have sine of x times cosine of x. What do I want to write this as? I want to write this in terms of tangent. Okay, now I'm able to do a canceling, and this is equivalent to the cotangent, but it tells me specifically that I need to, by the way, notice here that I can't have sine ever equal to 0, but I notice here I can't have cosine equal 0. We need to keep that in mind, otherwise the denominator would equal 0, so I can't have a fraction. Okay, so how do I still write this as a tangent? Well, I know that cotangent is 1 over the tangent. Okay, so all of this is true, and then I need to add when the sine of x does not equal 0 and the cosine of x does not equal 0. Why again is that? Because look up here. If sine of x is 0 or cosine of x is 0, would be in trouble. We'd have 0 in the denominator. That's fine. Alright, let's get started here. So as I spoke about in a previous video for these FRQs, recall, just like we say, adding and subtracting are going to be opposite, are inverse operations, multiplying, dividing, squaring and square roots, and so are sine and arcsine, or tangent and arctangent, or cosine and arccosine. Let's see if I have enough room here. First I'm going to replace m of x with 0, so m of x equals 0, so 0 equals, this is like arc cosine, so if you prefer, feel free to, if this helps you out, feel free to write arc cosine of the tangent of 2x. Now I want to remove that arc cosine, so opposite of arc cosine is simply the cosine. Cosine of 0. Arc cosine, again, you could just leave it as this if you prefer inverse cosine, that's totally up to you. Okay, so these two are going to be eliminated, and now I have the cosine of 0 equals the tangent of 2x. Okay, well at 0, we have a cosine of 1. It's 1 0 is the ordered pair. Cosine is the first number in the ordered pair. So I have 1 equals the tangent of 2x. Now I ask myself, when is the tangent equal to positive 1? Okay, so when is the tangent equal to positive? Well, right here and right here. All-star trig class, and right here at this 45-degree mark. So at pi over 4, and then notice every time we do a half circle, which is equal to 180 degrees or pi, we land again at that position. So this value plus an additional pi times n. So I have, okay, now we're going to do, so I have here, I have 2x equals 1/4 plus pi times n, where n is going to be any integer. But then I have to divide by 2 or multiply by 1/2. I have to multiply this by 1/2. So I get x is equal to 1 pi over 8, so 1 pi over 8 plus 1 pi over 2 n. So here's our answer, where n is any integer.